Okay. One, thanks everybody for coming. I'm glad folks have an interest in this topic. My name is Ben Cox. I'm on the council advisory group for the AI for Good Foundation. My current title is a director at H2O.ai. It's a machine learning AI software company. A lot of what I've done since I started about 2 years ago is around research and thought leadership in the space of what is ethical AI. You'll see we have some different terminologies for it, but kind of how to think about it. So with that said, let me stop my video, share my screen, and I can kind of walk through what I've got for folks today. Hopefully everybody can see my screen. And obviously, Lindsay, let me know if there's any tech hurdles or something gets weird as I'm talking, and I'll stop. Okay, so first off, let me disclaimer and say the way that we talk about ethical AI at H2O is sort of responsible AI. I'll come back to why we have that stance and explain sort of how we see the differentiation. But let me just kind of start off with some context and say that, like, a lot of times when we are talking about frontier technologies, there's a big pushback on any kind of, the move fast and break things idiom has taken hold of technology. But I think with machine learning and AI, we do have to ask, why does this matter? And I'm not typically one for kind of verbose quotes, but I think we do this. We're playing for higher stakes when we're talking about bringing in machine learning and artificial intelligence, which are decision automation engines, which means you can create a lot more damage much faster than typical kind of manual innovations or things like that. So, this quote I think is poignant because it's just important to know that the risks are much higher when we're talking about, my first job was in high frequency trading, and we made billions of trades a day. And if you were in the financial services business around 2011 to 2015, you saw a lot of similar companies get blown up because an algorithm went rogue and it basically bankrupted the company within 30 minutes. So I've had firsthand experience since 2012 of the materiality of things going wrong with respect to big predictive models. So, I think it's important to kind of stop and just, I should refresh this. I made this slide maybe a year and a half ago, and there's been about 1,000 slide, headlines like this since. There's a group called Partnership on AI, and they have an AI incident database. And basically what that tracks is every time you see a headline like this, where essentially an AI broke and something bad happened. Now I want to stop and also say, it's not always the AI doing something bad, right? Like, it's most of the time, I would argue that it's actually the machine learning model is doing what it's supposed to, but what's not being considered is the data that's being put into it, what went into creating or collecting that data, what kind of algorithm was specifically used. So in these headlines, there's a ton of different delineations between what went wrong. And I'm going to kind of talk about some of the examples of why, a gender discrimination complaint is not the same as a Microsoft's, AI Twitter bot becomes very racist, right? Those are two very different use cases of what went wrong. But it's important to note, one of the things that comes up when you talk about adopting machine learning and what hesitance you kind of come across is specifically headlines like this. Like, obviously the Apples, the Microsofts, the Amazons really are pretty resilient to these kinds of headlines, but a lot of Target lost a lot of brand reputation when they had that recommendation engine predicting that this teenager was pregnant, right? So it's really, really important to understand the kind of brand and PR risk that you're taking on as you start to think about deploying machine learning models at scale. Okay, so what we sort of believe at H2O, and this is always adopting, right? So if anyone here has very staunchly differentiating stances, I'm happy to discuss. We put this out there about 1.5 years, 2 years ago. And largely it's kind of held up. We found a lot of people have kind of gotten in our lane and said, you know what, I actually like this take as well. But it's sort of the blind leading the blind, right? Like, there's a lot of people who say, oh, it's explainable AI, oh, it's interpretable AI, this and that. This is our stance, right? What we sort of say is that there's a much larger bucket besides just the pure play ethics component. like to do machine learning and artificial intelligence responsibly, you have to look at more than just potential bias persisting through from data to model to prediction. You have to look at, are you in compliance with latest regulations? You have to look, are you bringing in cybersecurity risk? You have to look at how interpretable or explainable models can be, right? So the way that we think about this, and this is pretty commonly held now to some degree, and it's worth just kind of calling it out. When we say explainable AI, we really mean you've built a model. What are the tools you have? Like, how many tools are available for you to explain it after the fact, right? Like certain bias metrics post hoc don't work on certain types of models. Like, it doesn't create the kind of infrastructure for you to run that calculation. So how explainable a model is depends on what kind of model it is, and then kind of teeing off of that. Interpretable machine learning is really thinking about the transparency of the model architectures overall, right? A linear regression is inherently more interpretable than a deep recurrent neural network, right? And that's important to understand the difference between the two, because as you think about, how just easy it is to grok what that model looks like is important for getting buy-in and getting adoption at the highest levels of leadership. And then so kind of needling in on ethical AI, when we talk about that, we really are talking about that bias, discrimination, and sociological fairness component of it. So I want to also caveat this by saying there's like a couple schools of thoughts around ethics. And I think there's one side of the camp that is very quick to say, oh, I'm an ethicist on this topic. I know it in and out. I know what the ethical frameworks are, who don't have any kind of, senior degree or experience in it, because there's a lot of kind of folks who opine on these things without having any qualifications. There's a lot of, Twitter pundits out there. And then there's also true folks who have PhDs in sociology, anthropology, and ethics related degrees, who truly can describe at a doctoral level the frameworks that they think about. And I think there's a healthy median. That's where we kind of try to sit, where rubber meets the road. But I would call out, I think the ethics group, I think it's called FATE or Aether at Microsoft, has this massive team of ethicists and other doctorates who really understand the kind of bigger considerations going on. So last two things I'll say, secure AI is specifically around privacy, security, cyber considerations. And I don't think this one gets talked about nearly enough, because I think it's a huge problem that we kind of glanced over as we got into the machine learning space, because we sort of thought that we're coming from statistics, not from software, and you don't need to debug statistics. You don't need to do privacy protection on statistics, but you very much do. You can hack models. That's very real. It's very possible. Adversarial testing and adversarial networks exist. And then human-centered ML. I'll talk about this in a little bit, but I think this has a big ethical consideration as well that doesn't get nearly enough conversation. So I will come back to that. And so just so everybody knows, I'm going to try to leave 15 minutes at the end of this so folks can ask questions. So if you have questions, feel free to type them in, and I'll try to, keep an eye on it, but largely we can circle back at 45 after and talk. So the AI risk iceberg, right? I think when I was a consultant going from bank to bank saying, hey, you need machine learning, I really got two responses if they were interested in the first place at all. And one was, oh, we don't have enough data scientists. We don't have enough quants to make it work. And then the other side of it was, well, I don't want to end up in the headlines if it goes wrong. And those are two fine questions. They honestly are. But there's a lot more that goes into this, right? If you don't understand the science well, you don't understand what kind of technical debt you're bringing, you don't understand what kind of cybersecurity issues you have, you don't know the risk that you're taking on, you truly do not understand how to quantify the risk and bias considerations that you're creating. And then coming back to that kind of human-centered machine learning piece, as you start to roll out technology, it's really important that you understand what that interaction with the people at your company is going to look like, right? Like, I've had a lot of banks and customers say, in my former life, say, okay, well, how many people can I fire? And I'm vehemently opposed to that kind of question, because it's not thinking about it holistically. So this is my favorite slide. In that note of automation consideration, when you start to think about transitioning decision workloads to a machine from a human, one, you really need to be able to understand and quantify the risks that machine and that system is taking on. You need to understand how many predictions are being made, what's the average implication of a prediction, what is the absolute tail risk of that prediction, and honestly, do you have a kill switch, or do you have something to immediately stop the system if it operates out of a certain band of expectations, right? And the other thing to consider is, what do you do with those teams as you start taking decision-making processes off of people's responsibilities? Do you understand what you're going to do with them as an employee? And I never think firing or just like laying off troves of people because you took away like some 20%, 30% of their job. It's really about taking those people who you hired because they were an expert and they were qualified to do the gig, and moving them into more profit driving exercises. So when we talk about these big AI transformations, what you really need to consider as well from an operational perspective is, how do we take those folks who now have certain amounts of more time and move them to more profit driving exercises? And I think that kind of human transition roadmap is not one that companies consider. And that's a big ethical consideration, because one thing that happens is if you take some role and you take a big chunk of it out with machine learning, hypothetically, you get rid of people, you downsize the team, and then you find out a model needs to be deprecated, a model is problematic, a model needs to be shut down. You are then in a massively disadvantaged position, because you can't really afford to shut off the model, but you sort of have to do it. Then you have to rescale these teams, and then you're in a talent crunch. And there's all of this kind of decision tree that you need to think about as you start bringing in automation to decisions at scale. So as I kind of called out with that with that headline slide, and all of these sort of tie together, but it's important to kind of talk about the nuances between human bias, data bias, and algorithmic bias, right? So let me kind of frame it this way. From a human perspective, I think we've all heard stories of periods in time where, whether it was because of policy or not, we were engaging in bad faith, right? Like the redlining days where we were preventing certain folks from being able to live in certain parts of the country, right? The problem is when that human bias exists, it persists in the data. So what you need to be thinking about as a company, if you've been a company that's been around for a while, if people have been the reason that data was created, do you know that they were operating in good faith? And do you know that what they were doing wasn't creating human bias, right? Because that will immediately persist through to your model, but full stop. So going one step forward, what that human input creates is often bias in the data. But that's not the only way that data bias can be created. A lot of times, if you're at a bigger company, you've had to do a digital transformation where you're moving from SAP to Oracle to Hadoop to this and that. You have this Frankenstein of digital systems, and now it's hybrids of clouds. But what that doesn't sort of call out is that oftentimes those data pipelinings to whatever you're trying to do is not lossless, right? So you have these points where data that's being collected for machine learning exercises is not representative of the full data set. And even if it was, do you know that that's an unbiased set, right? So a lot of times data collection, creation, observation can actually create nuances. And sometimes we'll do this example with a credit card data set. And it actually shows that the model is being biased and overweight negative against people in the marital category of other, because there's just not a lot of that category. And that's kind of just a balance issue. So there's a lot of kind of statistical sample size and data collection considerations that you really need to know as well, that I think a lot of times people are so eager to build a model that they don't think about, do we really know how this data was collected? And I think, again, Partnership on AI does a phenomenal amount of research and conversation around, actual, data legitimacy and data collection. So if that's an interesting area to you, like that's a place to look as well. And then I think algorithmic bias. Here's the one where it comes to a lot and people really want to kind of hit the nail on the head. The two examples I'll give here, because I think way more than people think exist in the human and data side, but two examples that come up a lot, and they aren't completely unrelated. In algorithmic bias, we talk about, let's say, computer vision, right? Like there have been plenty of papers saying that computer vision is biased against people with darker skin tones, right? Part of that is a collection aspect, That's definitely true. Part of it is sort of how the math works of computer vision models, where you think about the contours and the shadings of certain pixels versus other pixels. So you have to understand the math of these algorithms to understand, okay, is it actually just there's a lot less representation for minorities on photos on the internet? Yes, but also is the model kind of perpetuating something just on the way that it runs calculations? Also, yes, to a degree. And then also what we're seeing too on a lot of these massively big natural language processing and pre-trained language models is they are also biased, because a lot of the internet is written by, majorities of populations, right? So if you look at how, I want to say it was GPT-3 compares different religious texts, it carries certain negative and or positive weightings to certain religions texts, right? And that's important to know, right? And you probably are not a person who's gone and trained that trillion of data point model, but it's easy to use things like GPT-3 or NLTK that are pre-trained language models and BERTs and Elmos and things like that. So it's important to understand the human component ultimately as it appears in the data component, and then how it persists into also pure play algorithm components, but larger pre-trained algorithms that you might be using out of the box. This is always really hard. Like, what is fairness? There's like a really good YouTube video on, like, I think it's called 23 definitions of fairness, because it's hard. Thinking about parity, bias, discrimination, equity, and fairness is a very hard problem. So I think Tia has shared a paper that we got published a couple months ago, that we worked on for a while, which was sort of just talking about how we see fairness. Now, it is not conclusive. I will be the first one to say, like, we are not done. I don't think anyone's done. But the way that we first order think about finding fairness in machine learning is using something called disparate impact or disparate treatment. There's a lot of tools for it, and there's a lot of different sub metrics you can use. I don't want to get into the math, but that's where we start. And you can start to see if certain populations are having adverse impact or marginal inequities. And I think that's really important to be able to do. So just shameless plug, you can check out some of what we wrote. It's very dense, but it starts to give you some context of like how industry leaders are thinking about the math of fairness, which I don't think, I don't, so let me also say, I don't think this will be solved. I don't think there is a solve. I think we will get progressively better and progressively closer and progressively find new challenges and find new ways to work around them. But I don't ever think perfectly fair and perfectly ethical machine learning is a solved equation, because the inputs are humans, right? And we are notoriously not rational actors. So we will always be doing this correction and overcorrection and undercorrection game based on how people are behaving and what kind of data they're creating. Regulation, I think this is really, really important. I don't really want to get into this because I don't think anybody got on this call today wanting to hear about government policy. But I will say every developed nation is looking at this as, how do we start to put some rails in place around our AI, people deploying AI in a way that will make it easier for us to understand what's going on and give them more ability to explain themselves when things come down to it. So I also wrote a paper on this. And what I would say is, if you're thinking about, okay, I'm deploying AI at my company, or I'm thinking about a place to deploy AI, I'd look at the top 6 of these bullets, because I basically went through 5 or 6 leading upcoming regulations and said, look, what do they all call out? Like, what do they all check the box on? And it's the top 6 things here. There are some things that I think are more important. There are some other things that are worth discussing. But I really do think that it's important to keep an eye on this, because again, if you don't, you're just creating long-term technical debt for yourself as a practitioner. Okay, so I'm going to get into just some of how things actually work, where rubber meets the road. And I'm going to kind of try to talk through it a little fast. Do I need to upgrade this meeting? Let me try.
I'm working on it.
Okay. I had to know if it was through my account. Okay, so for a while, when we talked about bias and ethics and fairness and explainability in machine learning, it existed in this one step of the process flow. Like you'd go do your data prep, your feature engineering, you'd build your model, and then afterwards, you just kind of review it. You run some metrics against it. You'd run disparate impact, you run PDP, you run Shapley, and you say, okay, this kind of checks out. We're good to go here. And that's honestly when I started at show. That's sort of how I saw things. We and I very much disagree now. As I sort of called out with the data and human component, when you think about fairness as it pertains to machine learning, I mean, it starts before you've even gotten the data, right? It starts the minute you think about an exercise. And are you designing an experiment from a place of unbiasedness? Or are you starting this experiment looking to confirm a thesis or a hypothesis? Right? So it's really important that the minute you start ideating on what you're trying to solve for, and as you start collecting that data, you know what data you're collecting, you know where it was created, you know the collection methodologies and the sample methodologies that exist for it. And then you start to think about how you design that model, because I think most folks should know here, I don't know how much folks model, but there's a very real way to overfit and underfit. And data never lies, but you can lie with data. And it's very easy to build models that just are a pure confirmation bias exercise. And it's important to take the time to think it through and give yourself some constraints and understand, do we need to monotonously constrain this exercise? And then I sort of will talk about the methods that we use to see if models are fair after the fact. And then one thing that I won't really talk about, because I think it's a little more technical and in the weeds, is around, okay, so you've built a model, you determined it's fair, now you're going to put it into production, so what? It's really important as you go out there and start to do this, is to think about, does your technology have the infrastructure to be able to, in real time, tell you if this model is getting more or less fair, one. Two, are certain potentially problematic features becoming more important, right? So these are all things that are important to know as you start to go think about deploying ML at scale. So we published something not too long ago, which was essentially talking about a proposed model risk management workflow. And I know that sounds like a mouthful. What I only want to talk about here is that a lot of data science exercises still to this day go on in kind of very free-flowing lab incubation type environments, and there's no kind of process behind it. There's no kind of linearity to how you think about building data science. And if it seems like I've deviated, it's important to kind of bring it back home. You can't consistently build fair and ethical models if you don't have process around it. And I'm not one for process where it doesn't belong. I'm all for kind of, experimentation where it needs to. But in order to be consistently comfortable that your models were built in a fair and responsible fashion, you need to have a workflow. And so this is what we propose. I don't want to spend a lot of time and go into all of the kind of, nuances of this. But what you need to understand and what you need to see is that everybody in the organization is involved in this, right? The business groups that ultimately create the data. Sorry, I keep coming back to banking. It's just where I come from. For instance, when you think about creating an algorithm that predicts whether or not somebody will get a loan, many times in the training data, the person who was deciding who got that loan before a model existed was sitting behind a desk in a branch, and they got an application and they went through and checked a bunch of boxes and said, look, okay, with this credit score, with this level of income, with this much cash in the bank, we can give you this rate, or we can't give you a loan. And so that created the training data. That's in a line of business that just is operationally creating data. And you need to understand, what's going on in those branches. They go through and check off those lists, and are they following process, and do we know how they're creating it? And then once you have the kind of data science and analytics teams, you need to understand that the data science process that they're going through is one that's kind of an intelligent framework, but it's also auditable or documented, so you can kind of have some accountability framework. Because in all of those headlines that I showed you early on, I'd be very pressed for you to show me who got fired because of it. We've gotten a lot of artistic license in the data science business for a long time to be able to fail pretty wildly, and nobody's losing their job. And I don't think, anytime an experiment fails, somebody should lose their job. But I do think there needs to be an accountability structure, or else exercises aren't taken seriously, and you don't actually, you aren't building models like you have skin in the game. And then finally, what we sort of propose as well is every company of some sort of size deploying machine learning as a core function of its business should also have some sort of internal, GRC, governance, risk and controls tech group, because once these models get put into production, you really need to understand what's happening, because these are living, breathing things, right? They change over time. They permeate, they create variance. You really need to understand and monitor what's going on. And it's great to have these sort of accountability systems of people just sanity checking machine learning models before they go into production. And then, we sort of propose this hierarchy, right? I think what is happening and what you'll see across a lot of the conversations of ethical, responsible machine learning. And I know, I think this isn't like a necessarily like spicy topic to talk about when you think about the ethics. I think there's a lot of kind of like wanting to be poetic conversation about the ethics of things. But I think also there's just a very real conversation that has to be had about, okay, if you actually want to be ethical and responsible, how do you build that team around it? So this is our sort of proposed hierarchy for larger organizations, right? Like, where do the teams that are building models sit, and what is that kind of structure of getting that, validation and monitoring and kind of risk and control testing on top of these lines of business that are creating data at very alarming rates. And I'm just going to keep saying, because this is one of the things I spend a lot of time talking about, I think everyone has seen the Moore's law of data creation and compute, right? We are creating so much more data than we have ever known what to do with. And this changes, this accelerates every 6 months, every 18 months. And so in order to be able to just realistically try to adapt as fast as we want to, without creating a ton of moral hazard, you have to build these types of frameworks. There's no other way you can operate in a stable, predictable, supportable fashion if you don't build these infrastructure rails into place. So I don't want to get too deep into this toolkit. I'm going to walk through a couple of the tools that you can use to determine fairness in models, and that you should look at when you're looking for fairness or sort of like ethical red flags. I don't want to get into the math. I just want to call them out so you can be familiar with the terms. And then if there are more questions about said math or what's the difference between A and B, feel free to reach out. So when we talk about, when you're actually talking about kind of fairness calculations with ML and AI, often it'll be some subset of disparate impact, right? This enables you to take some category of a variable and say, okay, if we want to see if females are being treated disparately, and we use males as a reference category, and then we, put it through the model, and we find there's some adverse impact of 20%, you can start working back from there. Right? Some tools can do it automatically. Some you have to really kind of just stop, go back to the data, think about what might be going wrong, kind of investigate the confusion matrix of true positives, false positives, that kind of thing. So the next few ones I'm going to click through kind of fast because I want to be done in 6 minutes and open it up for questions. But these are the tools that, like, in the trenches are the ones that I use, right? There are new ones coming out every day. There's new papers coming out every day. I wake up stressed trying to keep up with what's coming out every day. But these are the things that I still like the most. And it's, worth being aware of, as I don't know how in tune everyone is on this call, but it's important to be aware of and conversational about as you start to ask people you interface with about AI. So Shapley values are basically the gold standard for kind of feature importance. If you build a model, you get attribute and feature importance for that one model. Shapley is a way of kind of figuring out at the macro level how important certain features are, and that can be transformed features, or that can be just a column itself. It can be a specific state, it could be a country. So this is a very good way of finding out what things are important, and you can kind of visualize it in a couple ways where you can say it's very important in a very negative and or positive way. So Shapley values are one that come up a lot. Surrogate decision trees are one that I also like a lot when we talk about interpretable machine learning. Being able to show the decision tree that your model is traversing to come to a conclusion. So for instance, this example that I have up here is about the Titanic data set. When the Titanic crashed, who lived? And what you find is that some very important features are gender comes up, then what cabin you're in, and how old you are. So this kind of attests to the whole women and children first thing, and that's like an interesting concept to see visualized through a surrogate decision tree appended to a more larger model. Partial dependency plot. This is not a great visual to explain what's going on, but basically at each level of a feature, for instance, one really good way to think about this is if the feature is tenure and you're talking about a cable company, you want to find out what is the tenure that groups have that churn the most, right? And if you see a random big spike of churn at 5 years, you have to wonder, like, what did you do specifically? Did you create a 5-year, installment plan, that kind of thing? So it tells you across the entire, categories of a feature, what is the average prediction? And that paints a really interesting story in some cases. Sensitivity analysis. This one's way more complex. I'm really not going to get into it, but it's the idea of it's a what if analysis. If I change this one predictions, one feature to another thing, if we were to change everything and increase it by 20%, what happens to the model at the aggregate? And what that tells you is a lot of kind of, okay, if I'm going to sandbox this, what would it take to get somebody from a no, you don't get a loan, to a yes, you get a loan? And if any of that is sort of an ECOA or protected feature, which shouldn't be in there in the first place, you've gone wrong somewhere. Export decision tree, rule-based systems. Okay, I don't really get too deep here either, but a lot of companies want to do machine learning to find out what a really good model would look like what kind of decision tree is that model going to create. And a lot of companies aren't okay with a model that refreshes and changes its success in my career, is building a big model system and get sign off at a point in time. Now, wants to come back, run a refresh once every month, once every year, that's on them. But what it allows you to do is, instead of thinking about what is fraud at a bank, like if you do a $10,000 transaction, do we know that number is based on something material or a law? So what you can do is you can build a model that finds more nuanced decision trees, and then pull that decision tree and use that as a fixed prediction system. And then if you want to kind of create a living, breathing model, that's your prerogative as well. So we've been writing a lot on this. A lot of these are pretty technical and pretty gritty. I don't know how much folks are interested in the actual core of getting in the weeds, but what I will say here is what we try to do, and what I would hope that people try to look for, is there's two tails on a lot of machine learning writing. One is what you see in a lot of typical media outlets, that's just kind of very top level talking about concepts, and it's kind of, I don't want to say puff pieces, but it's just not giving you actionable things to do, or it's just saying, hey, there's a problem that sometimes algorithms are biased, and be concerned. And that's great, but it doesn't give you anything to kind of go do to fix it. And there's the other side where it's, hey, we're a group that just built this new neural network variant that added a fourth order interaction feature that provides some level of some additional level. And that's also not that useful to 99% of people. So as you go look to learn more about this stuff, what I would advocate is try to find outlets that, not only propose a problem or a thing you need to be aware of, but also try to start proposing actionable things to do, not give you a 45-page paper on a very new type of neural network, but actually give you things that you as a human or a practitioner or as a person who's starting to consider adopting some of this stuff can actually go do or take into consideration. So try to find that middle 80 or a middle 20, I guess is how I would call it, of things you can actually go action. And then I guess the last slide, and then I'll open it up, is just, it's not about just being fair to be fair. I mean, that's enough in and out of itself. But by going through these steps and critically thinking at every level about what kind of bias and considerations your machine learning model might bring in, you do a couple things that just are just super valuable, right? Like you're decreasing the risk because you understand how much risk your model has. You can quantify it. You've created a much more transparent model architecture and model ecosystem. So when a generalist leader who maybe isn't, coming from a data science management position asks you, okay, well, what is this doing? You can actually explain it, and you can explain it with some visuals that make it much easier. Statistics is notoriously convoluted at times to non-practitioners. You prevent technical debt because you won't have to go back to the drawing board every time you discover something was slightly unbiased in your model, or a regulatory authority comes in and tells you, hey, you are operating in severe lack of compliance with what we believe is good practice. And you get a deeper understanding of your data. When you create these metrics, analyzing what went on under the hood of a machine learning model, you've basically created really robust metadata, right? The same way that we track banking, like digital platforms, like journey lines, like, okay, they went in to check this account, and then went in to check this account, and then they left. This is essentially what you're doing for your machine learning model. If you keep track of Shapley values and DIA, disparate impact values over time, you can paint a really robust story of, is your machine learning getting better? Are you getting better at understanding your customers? Are you getting closer to the root truth or the ground truth? And then just increase agility and resilience. Like I think a lot of models going into COVID were super overfit because we'd had this really long linear bull market that really didn't have that many exogenous shocks. So the more simple, and this is going to be a really like tricky concept, is the more simple you can get a model that gets the amount of accuracy that you want, the more resilient that model is to uncertainty. It will be more stable and more robust to exogenous shocks. So all that being said, there's just a lot that goes into it. Understanding at the ground level what is fair is hard, but it's a work in progress. And being able to kind of start taking action on this gives you the ability to prevent yourself a lot of pain and drive a lot of value at your companies as you start to think about where ML fits into the larger picture. Okay, I'll stop talking there. And Lindsay, if there's any questions, I'm happy to take them. Also happy to give time back. Just let me know what we want to do.
Yeah, I think we'll definitely move to questions now. Thank you so much. This was so interesting. I want to make sure all the fellows get a chance to ask their questions, but anyone can jump in at any point.
Sure.
So I have a quick question. Regarding to the beginning of the of your presentation, you were talking about how all of these things can be either data or what's it called, like real world, like how the math works behind, let's say, computer vision, right? How would you, I guess, what I'm sure, okay, so my question would be, how would you like make sure that this is the best, let's say, as of now, right? Because AI changes every day. So how do you know, like, it may not be good today, but it could be good in like a month. How would you know, like, how to improve it? Maybe you would do the improvements, or maybe it's just the data. How would you know what is the issue? Like, at least the way you would solve the problem. And of course, how do you know that this is, I guess, a bad solution overall, or it could be a possible solution in the future? So you could pitch that, let's say, to the business or a client.
Yeah. So the answer is that you like never really, it's hard to know, and things change a lot. Like you'll see on one day that somebody has proved part of some big BERT NLP algorithm is biased against certain types of folks. And then you'll see a week later that, okay, we actually went in and we solved this, right? We figured this out, or we unpacked some of the bias that was sitting in that model. Um, and it's hard. So as practitioners, you sort of have to stay on it. And partially, let me think about my next few words very carefully here. So there's a few things, right? I think on one side of the coin, you have to spend your time trying to be aware of what the latest state of affairs is with certain type of trickier models. The computer visions and language are very top of mind. I think one side of the coin is when you run exercises, one thing that I do to kind of test data, I don't know, I don't know if a statistician would back this up, but if you create a model and you get some output, and it's you get this confusion matrix of true positives, false negatives, true negatives. I always like pull it back out and I run additional analyses on like each of those quadrants and see, okay, are we seeing weird clusters of behavior in true positive or true negative? A lot of what you can do to kind of bolster confidence is a lot of just post hoc analysis. There's just such this knee jerk reaction to, okay, the model compiled and I got a 90% accuracy, like ship it. And it just cannot be that way. So there's a lot of kind of industry monitoring, industry awareness. There's some work that you can do on like, if you really want to get under the hood of computer vision, which I've tried to several times and I'm just not smart enough for it. But there's some math to show like why certain things lean certain ways. But also I think in general, data still tends to be a big problem.
Yeah, that would lead me to the next question. So like data is a issue, but we have a ton of it. A lot of it could vary from different degrees. How would you clean it or make it better to prevent biases or just stuff that you're not looking for?
Yeah, so there's some science in things like SMOTE and ROSE, which are it's like synthetic minority oversampling technique. I want to say it's called, which was basically you can kind of figure out ways to, in smart way, underweight, overweight certain areas. I think if you actually have a data surplus, what I've started to do is you can sort of use like machine learning to find the examples of bias, right? Like, so if you go and make your build your model, and there's a bunch of predictions that should have been one way and went another, and the model was like very confident that it should have been this person got a loan in this test set, but they didn't. You can kind of go in and unpack what the features of that delta were, and say, okay, there's a bunch of examples in here's an example. I'll use a real one that happened. There was this. We were working doing financial crime analytics for this bank, and we kept finding that a lot a lot of these loans should have been turned down, but they kept being given at this one specific branch. And so what we actually did was we found that there was this disparity between what the prediction should have been by the model standards and what it actually was in historical fact. And we found out this one branch was just operating wildly out of protocol. And so you can do this exercise where you find the delta between P and P hat, or your prediction and the actual, and say, okay, can we find some commonalities in that population and strip it out? And if you can figure out from a business perspective, like from our answer, it was, oh, this one branch of this bank is just absolutely wilding out in Florida, and it needs to be kind of reined in. You can start pulling some of those out, because that's sort of going to taint your model going forward. So there are ways you can sort of use the output of your predictive model to also isolate the populations that are really kind of anomalous. So there's some overbalancing, underbalancing thing. I'm not positive if the math there is like agreed upon yet, but anomaly detection, a lot of those kinds of exercises, low quality data. Like, so one thing that I always do, and at some places this is like a standard, some places this is like a real novelty. When you start an exercise, you can run a visualization of across all of the data points, like which are sparsely populated. So a lot of times you'll pull a data set at a company and there will be like 100 columns. And then for 80% of the data, 30 of those columns are missing. So you just have to start throwing bad data out because it's like, okay, this is just going to mess things up. And obviously all of this comes from a business perspective as well, where you have to think about, okay, you have to go talk to the people who made the data or created the data. But there's a lot of kind of like algorithmic data quality checks you can do up front to, at the very least, identify potential hotspots of highly correlated features, things that might be proxies, things that are very unpopulated, or sparsely populated, so you can start to clean it up. Because I also had a job recently where we were dealing with transaction data across hundreds of thousands of stores in the US, and it's the data quality is like the very first thing you have to address. Like, some things just do not have the quality that you need to be using for analysis, or that you shouldn't be taking into a predictive model. So happy to take that offline and show you some of the things and tricks that I use to just kind of get a holistic picture of the data quality up front. But to be fair, it's also a $1 trillion industry of data quality right now that everyone is trying to figure out in a way that doesn't require 1 million data engineers. I don't think that's ever going to be possible, but there are some tricks you can use to kind of make your life easier from a data perspective.
Thank you very much. Those examples were very insightful. I really like that. And I would love to take it offline too. I would love to see the real world application of all that.
Yeah, no, I need to fire up a notebook, so it gives me a reason to get back in the weeds.
Hey Ben, thank you so much for the seminar. I think it was really insightful, and it's just something I'm super interested in. So I really enjoyed it. I kind of hesitated to ask a question at first because I don't really know how to like narrow the focus of this question down, but I'm gonna try. So I'm speaking kind of like from my perspective of like an AI beginner, basically, someone who's still just like learning how to do things. How would I go about, like doing like detecting bias? Like how do I, or, I mean, making secure AI, all the things you mentioned in your seminar, like how does someone kind of learn how to do that? Because it sounds like some of it's pretty complicated. And I think I'm getting to the point where it's like, it's becoming really important. Like the work I'm doing for AI for Good this summer, it's, eventually we'll go into production. But I just think, I myself, I have certain biases, and there's some things that I just can't really detect on my own, whether that's because of my, my identity or just like my AI skills, I guess. So how do I go about starting with that?
Yeah, so I mean, there's all the obvious kind of like data science basics, like getting up to speed on how to like, load, prep, clean, process, explore, model on data. And then it's about, I'm happy to, if you email me, I'm happy to send you like all the packages that I know of that I like, that allow you to kind of, once you've built a model, like quickly use like some kind of fairness tests. And then a lot of it, unfortunately, like this isn't a great answer, but it's about like spending some time in, unfortunately, like the readmes and the gets and saying like, okay, this is what I'm looking for. And I have some tutorials that we built. I hope they're still public, but I know where we can find some tutorials that talk about understanding sort of the fairness metrics, because disparate impact math, which is just like what I use most often, there's some other ways to do it, can get super, super heady. And it also breaks on some data sets. It's some data sets it just doesn't work. And so it's right now, because it is sort of blind leading the blind, there's a lot of just like, unfortunately, spend some time with it. The stack overflows, the stack exchanges, like that's not an ideal answer, but I can link you to some things that help me kind of figure it out and wrap my head around it, because I still have to remind myself how some of the math works like pretty regularly. I have to reread our paper that we wrote a couple times, like a month, because I keep forgetting. And it'll get easier. I think we're going to get better. Like I think we're at the period where we're finding we're going to get to a place where we start making better UIs and UXs for the output of these metrics. Like statistics in notebooks and in coding UIs is historically just not easy. And I think we're reaching an area where all the big tech companies are saying, like, we've got to think of an easier way to display this so people can actually intuit it, because we also want to get past just pure data scientists. So like a credit card analyst, non-data scientist could see it and say, okay, this is unfair, right? Like, how do we get to that point? And that's where, like, I think we're all kind of like progressively working now, is to make it easier for folks like you and to get more scale out of the actual analytics that we're getting.
Thank you. That makes me feel a lot better. So.
No, this stuff is brutal at times.
It's a little past 11, and so if anyone has any final questions, we might have time for one. Ben, I don't want to speak for you, but if you need to head off, that's also perfectly fine.
Yeah, I got time, but happy. Obviously, anybody ping me with any questions, I'll do my best to answer them. No promises.
Okay. I want to be respectful of everyone's time. So if anyone has any pressing questions they want to ask here now, please do. If not, please send Ben an email after. I'm sure he'll get back to you.
Can I ask one quick question? I forgot to mention it. When you were mentioning about security, I read an article about a research group that found that a deep neural network was broken just with 1 pixel removed from an image, right? And so it made me believe, because this area of AI is new, and rather the cybersecurity side of AI is even newer, trying to break these things, seeing how to secure them. What do you think of that? How do you think we should protect the models from attacks like that? Like maybe a user would go and put, I don't know, random characters, weird names, and probably fool AI. And like when it comes to the financial, maybe get more loans, higher loans, less interest, just stuff that will benefit them. I don't know how new, if stuff like that has been done already. Yeah, I would like your insight on that.
So the turtle or a gun one is pretty common. That one like really resonated in the news. And I will be quick with this answer, and I can send you a ton of stuff, because one of the people I used to work with has now moved over to the security side. And it's, if you guys want to get wealthy, going into AI and machine learning security is probably what I would do now. I think it's woefully underserved. We know a lot of different types of hacks that can occur. So like what you're describing is what we call like data poisoning. There was an example where in this election cycle, one of the candidates, like there was this big data poisoning exercise where they said, all these people signed up, like, we're going to go to this rally. And then it was literally just, Korean Twitter got a hold of it and nobody actually went. And it was this big fake out. And there's in the Microsoft AI Taybot was another data poisoning exercise where they set this bot loose on Twitter, and Twitter did what Twitter does. And so that's one example, and it's how do you prevent data poisoning? There's also really tricky ways, like from a lending perspective, what happens is kind of reverse engineering, where you ping up a bunch of loans, like you create a bot to go try to get a loan a bunch of times, and it gets told no 1,000 times. It eventually starts getting yeses, and you can reverse engineer the weightings of that model because you pinged up that system so many times. And from that side, that's when you want to have a machine learning model that has a kill switch, because if you have, 10,000 requests coming in from a day from a server farm and you don't know where, you want to be able to kill that. Like you want to be able to shut it down and have some anomaly detection going on there. And then there's also some kind of adversarial testing where you're thinking about if an adversarial model is trying to like break ours and adjust the weights of ours, how resilient are we to those types of hacks? I actually don't know the answers to a lot of these questions. I do know the most common situations that come up in sort of machine learning security these days, but I can navigate you to some very good pieces because one of my old coworkers has now spent a lot of time thinking about it. He's way smarter than me. So I'd much rather give you a better answer later than mislead you currently.
Thank you very much. It's very, very interesting topic. Thank you.
Yeah, I mean, it scares me to death. That's
yes. Especially with the reliance on AI. Who knows what's going to occur?
Yeah.
That's a fun dark note to leave off on. So thank y'all so much for coming. Ben, thank you so much for this wonderful presentation. Anyone that wants this email after the fact, I will be happy to give it to you. But yeah, thank you guys so much for your time.
Yep. Thank you, everybody.
Thank you. Thank you.